Hello guys, this is Matlab exercise number 7. Exercise number 7. It deals with the RL circuits, and basically this is the RLC mixed circuit for RLC. So here we will write the code for RLC, which is the RLC, which is separately. It is not combined, it is the RL and then the RC. Okay, so first we say RL circuit, and analysis, we call analysis of different parameters, and this is the RC circuit analysis. So we do RL first. In RL we have resistance and inductance. Okay, so we are asking for resistance, inductance, voltage and frequency. Four values we have to input. So in order to input four values, we need four input commands. Four input commands we will copy from here. You have to remember the syntax, how to write the input. So this is V equals to, doesn't matter, the space doesn't matter, you can put just without space as well, no problem. Okay, so there we go, here is no space. So okay, so first thing is voltage RMS, so frequency, resistor and inductor. So once we have these values, we can further process the values using different formulas. First formula is the T is equal to 1 over F. T is equal to 1 over F. So takes the frequency, divide 1 over F, it will get the T, time period. Then we get the cycles. Cycles are given in the question. It's about 2 cycles, so we'll say 2 times T. 2 times T is always constant. If he says 3 cycles, you will change it to 3 times T. Next is the angle, the omega. It's called omega 2 pi F. Omega 2 pi F is usually common across most of the questions. We have omega, so we keep it as 2 pi F. Vm is the voltage, which is the Vm mean, square root 2 times V. So whatever the voltage is, square root 2 times the V. Okay, so V, this is the V. I'm not sure if this should be the V. So we get the Vm, which is the root mean square root 2 times V. Okay. So the next thing we need is the time, cycles. All right. So times, the minimum value is 0, the maximum value is cycles. Cycle will be 2 times the time period. If the time period is 0.02, by 1 over frequency 150 will give you 0.02. You multiply by 0.02 by 2, you get 0.04. So it will be like 0.04. Okay, so whatever is the value for the cycle, it will come here. Next thing we need is this part here. Okay. Okay. Yes, baby. What do you want? Okay. So is my 2 years old baby in the background. Sorry about that. This equation, V is equal to Vm times sine omega t. Okay, omega t, sine omega t. All right, omega t is within the bracket. So you multiply by sine of omega t, you get the V. The V is the Vt, which is the voltage over time. We could just say Vt. All right. So just to differentiate this V from the capital V. Actually, this is ambiguous. Small v will be ambiguous, so we use it Vt. Okay. XL. All right. This time XL stands for the capacitance. All right. sorry, it stands for the inductance, right? Inductance, inductance. So here we have the part B. We are now we draw the circuit diagram manually by hand, and we are actually doing part B. In the part B, we have to calculate VT and IT. VT and IT. All right. So VT, which is the VM sine omega t. Okay. So next thing is I. Okay. For I we need the Z part, which is the impedance. Okay. We got the impedance. Then we need the theta, which is the phase for RL circuit, and lastly we need the IT, which is this one, IT, VT. All right, so VT, IT. I'm correcting my previous file. So IM is equal to VM over Z. So Z is impedance. Okay, so this is impedance, and this is phase. Okay, phase. All right, and this is the mean RMS current, VT, current, root mean square, RMS current, which is the RMS voltage over the impedance. Okay, so IT, current over time, will be the Im times sine omega t minus theta. You subtract the phase. Huh? Next thing we need is the plotting. The plotting is quite simple. Simply we copy all these lines here, then here. So that's your subplot. First plot will be the quadrant will be the two rows, first column and the first plot. Okay, so it will be row column, and plot number. So plot number. Okay, so first is the row. So we need first row, the in first column, and plot number 1. This is why we do subplots. Then what you need, the first plot we need against time on x-axis. So this will be the first one will be the x-axis, and the second one will be on the y-axis. So values for Vt will go along y-axis, while the values of time will go along x-axis. So Vt is coming from this formula. It will be a matrix set of values that will be plotted against the set of values of time. Same thing for the second subplot, which will be the on the second row, first column, and plot number 2. All right, so that's quite understandable. We can just simply copy this here and put it here. Same thing. This time y-axis will have the IT values, which is coming from this formula, against the same time values that are coming from the range of values from 0 to cycles. When we run it, we get the two plots, add to path. We get the plots for the voltage. It's processing because it's saying waiting for input. Yes, we forgot to do this. So go back to the question and see what you have. The values is 5 ohms, 50, 100, 50. So voltage is going to be 100 volts. Enter. Frequency is 50. Resistor is resistance is 5 ohms, and the next thing we need is the inductance. Inductance is 50 millihenry. So 50 millihenry, you have to convert it into Henry. So 50 multiplied by 10 to the power minus 3. Okay. we should be getting plots after this busy is finished. So we got the plots. Okay, this is the answer for exercise number 1, which is actually talking about calculating the instantaneous voltage and write a program which receives the input on the plot. So part B will be your calculation and part 1 will be your drawing by hand. This calculation is going to be by hand. So part C is what we have finished just now in the form of plots generated by Matlab. Okay, so this is your answer and this is the code. Okay, thank you very much.